Hello folks, welcome back to my YouTube channel, and we are in the Python for Data Science module, and our today's topic of discussion is NumPy Broadcasting. Now, as the formula definition stated over here indicates that broadcasting in NumPy is its ability to perform element-wise operation on arrays, even if they are of different shapes or maybe they are of different dimensions. Even then, without reshaping, we can just try to match them each other following some rules that are these three rules, which we will see one by one. I have just stated it here so that you are theoretically aware of the rules. So let's jump into our discussion and how the broadcasting works. Okay. um Here you could see this image. In this image there are three parts to it. I have shown the addition of two arrays where the shape of both the arrays match, and we are focusing on what result do we get when we add. Then there is a second array where the shape is different, like it doesn't match, or you can say number of dimensions are different. Here we have two dimensions and here we have only one dimension. So how do we do addition, and how is the addition performed in such cases by using broadcasting? And then there are two addition of two arrays which have different shapes. In that case, how does the addition gets performed? These are the things that need to be answered, and this addition gets performed with something called as broadcasting. All right, so let's have a look at this additions one by one. I have replicated exact same thing in our code, that is exact same matrices I've replicated in our code. So let's jump into the code. As usual, I import a NumPy library first. Then I would create an array that looks like this: 0 0 0 10 10 10 20 20 20 and 20 30 30. So I use a type function and an arrange function to construct this array. So if I run this, I would get this array, and after doing a transpose, I'll get the array that is there in our diagram. So in first row it's all zeros, then second rows it's all tens, the third row it's all 20 and 30. So we have got this array. Just hold on, I got some error over here because I did not execute this either. Yeah, so I've got the array over there. Then I construct another array that is with the elements 0 1 2 in each row. All right, and here you could see that arr dot a and arr dot arr underscore b, these have the same shape. That is, if you want to see the shape of both of those, you would just do a arr dot arr underscore b dot shape. Okay, so not run this. Arr e shape. Yeah. So you would see they have identical shapes, and we don't need to do any broadcasting. We will get the addition of this first part of our image, or you can say diagram, as the one you could see on the screen here. Okay, so no broadcasting needed in this case. Now let's move on to the second part, or you can say a second case that we are dealing with right now. So here in the second case, what we have is these two arrays. You would see they differ in number of dimensions. So let's see what are the dimensions of each array. First, I would construct that array of 0, 1, 2, and I would check the dimensions now. ARR of A. First, I would check the dimensions of ARR underscore A dot end. If I do this, what do I get? 2. Then I would get ARR. I want this array now. I want this array now. So I construct that array, and then ARR underscore 2, and then again. I'm just checking the number of dimensions for both of. You would see there is a difference in number of dimension, and that is where we will have to follow the rules, or we will have to take the assistance of the rules to do a broadcasting. All right. So what the first rule says is, just have a look at, if two arrays have different number of dimensions, in which in our case it is the same. We have different number of dimensions. The shape of one with lesser dimensions is padded with one on the left. So here the shape of one with lesser dimensions, you would see here this one is lesser dimensions, and this array in this diagram is a lesser dimension array. We have named it as arr underscore 2. It has lesser dimensions. This is a two dimension array, this is a one dimension array. So what they are saying, the array with lesser dimension is padded with one on the left side, one on the left side of the shape. Okay, so shape of one with lesser dimension is padded with one on the left side. Now what will happen in this case is, if I check for the shape of arr underscore 2, arr underscore 2, arr underscore 2 dot shape, right? Okay, it's 3, comma. Now they're asking me to pad it with 1. So the resultant shape here would be after padding, it would be 1 comma 3. Sorry, 1 comma 3. I just added 1 on the left side of 3. All right. Now the next rule says that, let's see, if the shape of array does not match. Now we are able to match the dimensions. Now the shape, we need to match the shape of arrays as well. Okay. So if the shape of arrays does not match in any of the dimension, the arrays with shape 1 is stretched to match the shape of the other array. Now in our case, we have one array that is 1 comma 3, padded, that is with the shape 1 comma 3, and we have another array. Let's check the shape of that array as well. That is arr underscore a dot shape. Okay, so we have another array with shape 4 comma 3. What they are saying in the second rule, that whichever array has the shape 1, okay, you stretch it to the shape of the another array. That means to make this 4, I will have to broadcast this 1 comma 3, this array, with dimension 1 comma 3, sorry, with shape 1 comma 3 to uh, 4 times. I would have to broadcast this array 4 times, so that I would be able to change the shape of ARR2 to 4 comma 3, and that is what exactly will happen. And after this happens, the shape, after applying second rule, after applying second rule, the shape would change to 4 comma 3. Okay. Now, when the shape and the dimensions of both the arrays are equal, we can definitely perform an addition, and that is what it does when ARR plus ARR2. Now, if you look at the output carefully, we get the output easily because broadcasting is performed in the background. How it is done, that is what I was explaining with the help of the rules. All right. So it takes care. The Python takes care. Python, that is the NumPy library, takes care how to um, NumPy library takes care how to do a broadcast. You did not do anything, but then you need to understand what happened in the background. So this is how the operation works, and you still get the same result. All right. If you would have seen here in the diagram, even if the number of dimension is different, shape is different, then also you are getting this as an output. You would see here 0, 1, 2 has been stretched to match the shape of the another array, and once both of the arrays are of same shape, you get the same output. This blurred output is nothing but a broadcasted, this blurred part of this array is showing what is broadcasted. Now let's refer to the third case where you have these two arrays 0, 10, 20, 30, and the another array is 0, 1, and 2. Again, we will check with the rules that are the number of dimensions different, and is the shape different. So I have already constructed that array ARR1. Okay, I will just take the shape of this ARR1. ARR1 dot shape 1, and 1 dot ending. Say is ARR1 not defined? Maybe I have not run this. Let's run ARR1. See, I get the array dimensions as 2, and then again ARR score dot, you have array dimensions as one, which we have calculated earlier as well. So referring to our third part, or you can say a third case, where you have to do an addition of these two. Now the dimensions are different. All right. So again, the same rule. What the first rule says is pad the shape of array with lesser dimension with 1 to the left side. So lesser dimension to the left side. Okay. So following rule number 1, what will happen here is that you will check the shape first. ARR underscore dot shape. Okay. ARR underscore 1 dot shape. So 2 dot shape. Sorry. Okay. You would see the shape is also different. Okay. Now what it is saying, add 1 to the left of ARR. So after 1 to the left of ARR underscore 2, because it is with the lesser dimensions. Now when I do adding, what will the output be after adding 1 to the left? Shape will change to what? This shape will change to 1 comma 3, 1 comma 3. Now applying the, let's try to apply the second rule. What the second rule say is that if any of the shape is one, shape has one, all right, so you just do a broadcasting over there. Over there broadcasting is possible, all right. So we could see here ARR 1 dot shape has 4 comma 1 and ARR 2 dot shape has 1 comma 3. Now let's have a comparison from right to left. That is, as per the second rule, here we have in ARR1 uh, the in the axis 1, that is columns, we have 1, and in the ARR2 we have 3. So one of them is true, so we can do the broadcasting easily. And we will, what the broadcasting will do is that ARR1's column will be repeated 3 times. So ARR1 was what? Let's have a look at what is ARR1. I'll just retype ARR1 over here so that I don't have to scroll down up and down again. This was the ARR1. For axis 1, that is columns, we can do the broadcasting because we have ARR2 of shape 1 comma 3. So ARR2 has got 3 columns, ARR1 has got 1 column. So wherever it is 1, that array will be stretched or repeated, in this case to match the other, that is, that has 3 columns, so it will be repeated for 3 times, all right. And for axis 0, that is for rows, if you would see ARR underscore 2 has got 1, so that one can be stretched or repeated 4 times to match the arrays, so to match the rows of ARR 1. And after doing that, what will happen is that you would get the output that you see in the diagram. I hope the concept of broadcasting is pretty much clear. Here in this case, in part 3, we saw that we could broadcast both of the arrays. One broadcasting or one repetition was done across columns, the another repetition was done across rows. In the previous example, it was only one array that we did broadcasting, which as it was required. So it will be different situations in cases of different kind of arrays. And then there is rule number 3. If dimensions do not match, neither of them is 1. So what it says is, if there is no matching dimension and there is neither of them is 1, in the sense here broadcasting was possible because one of one of the um, one of the dimensions was at 1. But if there is no 1 here, like 1 comma 3 or 4 comma 1 in the shape, then you will not be able to do any broadcasting will fail. To give you an example, if array is of shape say 2 comma 4 and 4 comma 4, then the broadcasting will fail. It is not possible to do a broadcast. So that's all about NumPy broadcasting. I hope I was able to convey the concept because that was something that was important in this case. And I will see you in the next video with yet another concept in Python libraries. Thank you for watching.